Okay, in section 15.8, we're going to be taking a look at spherical coordinates. So that's going to be a third coordinate system that we can use to describe points and surfaces and solids and regions in 3 space. So we've got our rectangular coordinates. That's very familiar. That's just x, y, and z. And then we've got our cylindrical coordinates, and that's just r, theta, and z, where the z here is the same, and essentially r and theta are just describing x and y in polar coordinates. Then we've got spherical coordinates. That's going to be a rho, theta, and a phi value. Okay, so this is rho. That's a Greek letter. Theta we're familiar with, and these thetas are the same. So we already know what theta means here. If I had a point in 3 space and I project it down onto the xy plane, it would just be the theta that would be a polar coordinate for that particular point. Okay, and then this is phi. That's another Greek letter. Okay, so what do these things mean? Well, we know what theta means. Rho is going to be the distance to the origin. And that means that rho has to be bigger than or equal to 0. So rho will never be negative. Okay. Phi is going to be the angle made with the positive z-axis. And phi is also going to have some restrictions. Phi is going to be between 0 and pi. So let me just show you what phi looks like here. I am very much regretting that I left my toys at school. So here we have the XYZ coordinate system. Here, this vector right here is making an angle of 0 with the positive z-axis. So that would correspond to phi being 0. Okay. Now, I'm rotating down, so maybe now I'm making an angle of about pi over 6 with that axis. Okay. I don't have to rotate straight down towards you, though. That's also making an angle of pi over 6 with the axis. This is going back pi over 6 from the x-axis. Okay, so we're just talking about if you rotate down, if my point was here and I draw a ray from that point to the origin, that ray is going to make some angle with the positive z-axis. I want to find that angle. That's not uniquely going to determine where the point is. I'm going to need a combination of rho, theta, and phi. Now you might wonder, why doesn't phi go all the way to 2 pi? Because you'd think I can rotate down. Now this would be an angle of pi when I'm on the negative z-axis, but why can't I rotate back up and all the way around? Well, I could, but I don't need to. Because if I'm, let's say I rotate down pi over 6 here, well, to get to pi over 6 here, I don't need to actually rotate all the way around like so. I can just adjust my theta value so that my theta value puts me over here, and I'm making this angle of pi over 6 with the positive z-axis. Okay, so by combining theta and phi, it's okay to restrict phi to be between 0 and pi, so that basically 0 is pointing straight up. Anything where the phi value is pi over 2 would put me on the xy plane. This is also pi over 2. Again, I don't have to get there by rotating 3/4 of the way around. I can get there by just rotating pi over 2 down in this direction. Okay. There are no restrictions that our textbook places on theta. Some textbooks do put some restrictions on theta. Ours doesn't. So that's totally fine. Okay. So that's what these things mean. What I'm going to do now is I'm going to plot a point P. I'm going to plot a nice point that's in the first octant here. And I'm going to just label on this picture its coordinates in all three of these coordinate systems, choosing, when I have options, the simplest possible choices that I could make. So if this point is my point here, this would be the projection of it onto the xy plane. So I would basically get to this point by coming out a distance of x, over a distance of y, and then up a distance of z. And that would make that point x, y, z. Then the the cylindrical coordinates for that point, the z would be the same, but I would describe getting to that projection onto the xy plane differently. I would say this is my r. Here I'm making the simplest choice possible, that I'm choosing a positive value of r, which is what I'd have to do if I were integrating anyway. And here's my theta. Now that theta right there is the angle between the positive x-axis and the ray that points to the projection onto the xy plane here. This triangle right here is actually my familiar right triangle that we're used to working with when we're converting between polar and rectangular in 2 space, or cylindrical and rectangular in 3 space. That's xy theta r. The orientation of that is just a little bit different. Okay. All right, so what are my spherical coordinates, and what are they going to look like? Sorry, looking for a different color marker. Okay, well, if here's my point, there's my rho. Rho would be the distance from that point to the origin. Okay. Now, theta, we said, is exactly the same, so I've already got that. Phi would be the angle between the positive z-axis and the ray that would point from the origin to my point. I'm going to label my point P. Okay. So this picture shows us all of the different coordinates that we could have for this point. In that picture, I see this triangle, which is what helps me convert back and forth between rectangular and cylindrical. I can also draw in another triangle that's going to help me convert between rectangular and between spherical and cylindrical coordinates. These two have a theta in common, so I know they share that, but I want a way to go between r and z and rho and phi. Well, if I just take this line right here, this points from the origin to the projection of my point onto the xy plane. If I draw a line here, making a if I draw a line here going straight to the z-axis, that's just this line r lifted straight up. And this distance here is z. This is just r, z, r, z. There's a parallelogram that I have right there. So now I've got this nifty triangle right here that has r and z and rho and phi in it. So that's going to be really useful in helping me to convert between cylindrical and spherical coordinates. Now, where's my right angle? I'm hoping it's a right triangle. And it actually is. This right here is a right angle. This was pointing straight up. This is parallel to the xy plane. So that's a right angle. So I'm going to just redraw that triangle so that it looks like a right angle. I'm going to have rho and phi and r and z. So these two triangles are what are going to help me go back and forth between the different systems. I can rely on this picture, but this picture is a little bit harder to draw. So what I like to do is draw this picture once or twice until I feel really comfortable with these triangles, and then in the future I'm just going to go straight to these triangles if I want to convert between spherical coordinates, cylindrical coordinates, and rectangular coordinates. So that's where we'll pick up in the next video.